Hello, this is Deep Thoughts with Deegan. Today I'm going to be talking about how to take the derivative of the nth composition of any differentiable function. Okay, so it only works if the function is differentiable at the nth composition, which a lot of functions are. So to do this, I'm just going to use the chain rule. Over here, I'm just going to make a little table so I can remember all this stuff because I know all of this, but it's easier for reference purposes. So we're going to look at psi n. I'm going to put that right here. And we're going to look at the derivative of psi n, where this is the same n. So 0, I'm going to go to 3 for this one. So psi 0 is just f of x. So here it's going to be f prime of x. If you recall, psi 1 is f of x. So we're looking for the derivative of f of x, right? Just like that. All right, so to do that, I'm going to set up chain rule. F of x, f prime of x is our outside function. F of x, f prime of x is our inside function, right? Pretty simple. Plug in f of x. Now, if you remember, f of x is psi 0. I'm going to put in psi 0 times f prime of x. Because if you look at this here, look at that. You got psi, whoa, I forgot how to do words. You get f prime of x, and you got psi 0. Both of them have the f prime. And the order I'm going to actually write this down is f prime of x times f prime of, oh my god, what is that? Of psi 0. Okay, that's nice and all. So now I'm going to go f of x, right? Derivative with respect to x of f, and I'm actually going to do it this way, of f of x, which is f of psi 1 of x. I did this wrong. Parentheses are hard, okay? So right here, I already know f of x is my outside function. My inside function here is, first of all, derivative of f of x is f prime of x. Derivative of my inside function. My inside function is psi 1. Derivative of psi 1 is f prime of x times f prime of psi 0. All right, I'm starting to see a pattern here. Put it together. We're going to start here. F prime of x times f prime of psi 0, f prime of psi 0 times f prime of psi 1. Now the pattern at this point is starting to become pretty obvious, but just to make it 100% sure, I'm just going to go another one. And it's never going to be 100% sure. Let me fix that. There, I was kind of worried I was going to make that worse. All right, so from here, what I'm going to do is same thing I did before. F of x, we're looking at the derivative with respect to x of f of, in this case, I'm actually going to write it this way, of psi 2. Okay, so now what? Well, I'm just going to take f of x, f prime of x, psi 2. Then we got this long thing here, f prime of x times f prime of psi 0 times f prime of psi 1. This is very messy, but you get the idea. It's all the same. Wrong psi. Okay, so from here, look at that. We're just multiplying by f prime of psi 2 with this, which is just going to be the same thing, f prime of x times f prime of psi 0 times f prime of psi 1 times f prime of psi 2. Okay, well, now we can use a product to define this, right? And what does that mean? Well, we'd start with our f of x on the outside because, well, you'll see. I'm going to do it this way. We're going to have our derivative with respect to x of psi n of f of x is equal to, right? I'm going to start with f prime of x on the outside. F prime of x times. It's doing good. Yep. So I'm going to have a product. This is the pi notation for products. And for my counter, I'm just going to choose j because it's traditional. J is going to start at 0 because look, we have psi 0, psi 1, psi 2. And if you notice, for our third composition, it's psi 2. For our second composition, it's psi 1. 1 goes to 0. And we don't really care about the derivative of a function itself right here because, well, we don't need this. So what we can say now is we're looking at n minus 1 is 0. N minus 1 is 1. And so on. 3 minus 1 is 2. So we're looking from j equals 0 to n minus 1 of f prime, all of them are f prime, of psi j, the jth composition of f of x. So actually, that's it right there. And it works for every single function. Just to show how well it works, I'm going to show you a really big one. Simple, but really big one right now.